Interruption is a very common and useful technique in microcontroller programming. That few pages is explain what is interrupt and what is the advantages of interrupt. So you can read it, and it also have some link extra reading that you can be for your reference. Okay, and interrupt and polling is different thing. That's explain what is the advantages of interrupt and what the advantages of polling. And the structure of MCU interrupt, okay, to introduce there is external and some is internal. We will introduce external, most likely is an I/O triggering. Okay, some device changing their I/O status and inform the MCU to handle their request immediately. And timer is also one's most common internal peripheral. That means every millisecond to interrupt the MCU, like you do a stopwatch, that you need the timer interrupt all the time. And the sequence to handle interruption, okay, there has some dedicated floating for AVRO system. Different system will have different handling procedure or sequence, okay. And this is the board. I have two key, okay, for two different external interruption to generate two interrupt. But you have one, but don't worry, the exercise only need one switch, okay. Okay, then what is the timer interrupt? Have a lot of things, but we focus on the key timer on compare match. Okay, we call CTC mode. This is the most common type of timer interrupt. Okay, that you can see some Arduino system timer peripheral. Okay, and the equivalent circuits of an timer. Okay, they have different sign. This is timer 2 that we can select, because other function will call timer 1, timer 0. Okay, so we choose timer 2. Okay, and talking about their operation and some detail of the P scalar and the config, the control register. So we need CRT, CTC mode. So we need to set up this 2 pin with this mode. Okay, and then the P scalar. Okay, what's the config of P scalar? How the degree to divide with the system call. Okay, and then the output comparison mode, when the value of the type TCNT register, okay, timer counter register, the value will automatically increasing by after the P scalar call. Okay, we call timer call. After the timer call, let the TCNT, okay, timer counter reach with merging with the output compare register of timer 2, the register of OCR2 are reached and matched together. Interrupt request may generate it. But after generated request is not enough. We also to enable the interrupt. Okay, there is two OCR, so there is two different enable. Okay, and you also call with overflow only. Overflow, that means the counter have 8 bits. That means every 215.6 times they will generate. So up to you. If you dedicate for some timing, okay, because our clock is 16 meg, after you divide by 16 or some value, they may not can be derived or exactly find out with our time that you need. So you need to using the P scalar and the OCR to make sure that you get your exactly or closing value of the timer interrupt interval. Okay, and then you also have a mass global, the whole chips CPU program also can disable your interruption. Okay, and also one very dedicated thing is interrupt is look like a task, so that make sure that interrupt task should shorten as possible. Okay, don't make an interrupt to demand the whole chips for over a second. Always interrupt maybe a few statement and to complete it. Okay, because during the interrupt the CPU didn't respond with your other words. Okay, other interrupt again. Okay, if you have a multi-level, although you can enable the interrupt, but the system is quite complicated. Okay, and easy to get loose, because when you open interrupt in interrupt service routine, that means your stat and your calling procedure may come complicated and easy to get loose. Okay, so generally we will not enable interrupt in inter-service routine. So file 1 is quite easy, just changing our exercise 1.6, okay, by using interrupt. Okay, so let us to see the source program. Okay, 1. Okay, we have the pattern, and then okay, this quite long, so we focus on this. Okay, just set up and the loop. Okay, there is a setup, and the setup will show you to set up the timer counter, and this is the timer counter value. Most of the things just follow. Okay, no need to argue with them. For a beginner, follow everything. Okay, in the quiz you need to change the value of OCR and the P scalar, the timer control register B. Okay, that is mainly to control, to select the P scalar value, how the degree of the order to divide the system call. Okay, so in the interrupt, this interrupt setup, timer interrupt setup, also quite fast. That should be around in 1 or 2 milliseconds. Okay, so it's so fast for us to switch the pattern again and again. So after 100th time, you look like the time interval should be around 1 second. So I think this is a 1 millisecond interrupt interval. So every 100 times I'm using event counter, then passing to set up a thread to toast the thread, assign the thread to become true. And on the main, I check if the thread is true, then I clear that and switch to next pattern. So let's us to see it. Oh, because I connect a new chips. Okay, port. Oh, that is 12. Okay, set to 12. Then NANO again. Oh, that setup. The interval time should be not 1. Yeah, that is the previous program. Okay, not this one. So we can see that. Okay, the pattern switch quite slow, so that you can decrease the OCR to A. Okay, you reduce this number. That means every time we slower, you can change, and you can change the event counter. The number of event counter maybe 15 is half of 100, so that the speed will increase by 1. Faster, double. Okay, and you can change the P scalar. Okay, from the slide you know what the value they are. Okay, now it's 111, so we can read back what is the P scalar value. Yeah, 111 is divided by 24, so we can choose 110, but the clock is faster double and double. It's faster 4 times already, so the clock rate the P-scaler cannot choose a very accurate time. You need to using event counter to help you to choosing a right time, and using the OCR to control a more precise resolution to get your accurate timing.